Assalamualaikum and a very good day to Professor Dr. Amri bin Lajiz. My name is Siti Sarah binti Hassan and my matrix number is CN200-107, and I will present the individual assignment on the topic of sewing machine in automotive industry. So in the sector of economics, known as the engineering economy, decisions on engineering projects are made using the economic theories, principles, and methods. Finding the most cost-effective solutions is to increase the profit and reduce losses. It entails analyzing the costs, benefits, and the risks involved in every engineering project. The ability to make educated decisions based on economic principles is critical in the field of this engineering economy. Engineering economy is a subject that combines engineering skills with financial analysis to assess project profitability, to optimize resource allocation, and to identify the most cost-effective solutions. By this subject, engineers can make informed decisions that maximize the efficiency and profitability by utilizing economic concepts such as the time value of money depreciation and cash flow analysis. So the purpose of this study is to provide an overview of engineering economy and its importance in the field of engineering. It will delve into essential concepts, processes, and tools used by engineers to evaluate the project finances. By knowing these concepts, professionals can make well-informed decisions that will align technical objectives with economic feasibility, ensuring the successful implementation of engineering endeavors. And the main ideas of engineering economy will be introduced in the first section of the study. It will investigate the concept of the time value of money, which will recognize the value of money changes over time owing to factors such as inflation and interest rates. All procedures, including current, prospective, and annual worth analysis, will help engineers assess the financial sustainability of projects will be studied in this project. So the problem statement for this study is that the machine is making strange or weird noises in the workshop and the needle is not moving well while the machine is running. As for the objective of study, first one is to develop a sewing machine system that can automate and efficiently the stitching process in the automotive manufacturing. The second one is to increase productivity, thus to reduce the labor cost by designing a sewing machine that can deliver precise and consistent stitching. Another one is to consider the ergonomic factors in the design of the sewing machine and to ensure the operator's comfort, hence minimizing the risk of fatigue and injuries for the staff working in the automotive industry. And last one is to design a sewing machine that will provide a solution in balancing and performance and cost, such as aiming to provide a cost-effective solution that aligns with the automotive industry. This project is done because engineers in the automotive sector may encounter several issues relating to the sewing machine utilized in various stages of car manufacturing. Here are some potential issues that an engineer may face. The stitching accuracy, for example, and in the automotive industry, precise and consistent stitching is critical. Hence, engineers may encounter difficulties in ensuring that sewing machine generate accurate and properly spaced stitches, particularly when dealing with intricate patterns or thick fabrics. And to maintain stitch quality and avoiding fluctuations in stitch length or tension may necessitate continuous monitoring and correction. And the other one is engineers must ensure that sewing machine can adequately handle these various fabrics. And to prevent tearing or puckering during the sewing process, different materials may require different needles, thread kinds, or machine settings. Besides, sewing for heavy-duty sewing machines is capable of stitching through numerous layers of thick and resistant materials are frequently required in the automotive sector. Moreover, in the automotive industries, engineers might be facing problems from automation and integration systems. As the automotive industry becomes more automated, engineers may confront difficulties integrating sewing machines into automated production lines. This entails designing and implementing systems for material feeding, pattern recognition, and machine control to achieve seamless integration with other manufacturing processes like cutting, molding, and assembly. Maintenance and downtime, such as sewing machines, like any other mechanical equipment, it requires routine maintenance and may occasionally fail. Furthermore, to minimize the machine downtime and to maximize the productivity in the automobile production environment, engineers must design a preventative maintenance schedules and troubleshoot any faults as soon as possible. These are the example of some of year-digit methods of depreciation that were used in this study. Sum of the years digits methods, or the sum of year depreciation method, is an accelerated depreciation method whereby the method declines the asset's value at an accelerated rate. Most of the depreciation of an asset is recognized in the first few years of its useful life. Therefore, greater deductions are allowed in the starting life of the assets than in subsequent years, mainly in the case of those assets which are heavily used when they are new. The sum of years digit methods of depreciation will first undergo calculate the depreciable amount. The second one is to calculate the sum of useful life. Another one is to calculate depreciation factors, and last one is to calculate the depreciation for each year. The depreciation expense equal with remaining useful life divide with sum of the years digits time by cost minus with salvage value. For example, consider an asset with a cost of 10,000 ringgit, a salvage value of 1,000 ringgit, and a useful life of 5 years. To calculate the depreciation expense using the sum of years digit methods is by undergo these steps. The step 1 is to calculate the sum of the years digit. Step 2 is to calculate the depreciation expenses for each year, year 1, year 2, year 3, and year 4, also year 5. Step 3 is to calculate the accumulated depreciation of each year. Therefore, by the end of year 5, the accumulated depreciation will be equal to the asset's cost minus the salvage value. For example, 10,000 ringgit minus 1,000 will be 9,000 ringgit, which confirms the accuracy of the calculation. Besides, the salvage value is subtracted from the cost before applying the depreciation formula in each year, and this is a simplified example, and the actual calculations that may vary depending on the specific requirements and applicable accounting standards. So in conclusion, the sewing machine is critical in the automotive sector since it provides essential stitching for interior components. However, the efficiency, customization, usability, and maintenance might all be improved. Significant progress can be made by combining automation and robotics technologies, improving customization possibilities, developing user-friendly interfaces, introducing maintenance and monitoring systems, and fostering collaboration with vehicle manufacturers. These proposals aim to improve the performance of the sewing machine, enhance productivity, to eliminate errors, and to meet the changing demands in the automotive or automobile sector. The sewing machine in the automotive sector can contribute to the manufacturing of high quality, customized, and visually appealing automobile interiors by following all the recommendations from this project. Thank you.